Welcome back. This is 7.1b compound interest, more into exponential models. Little review. Suppose you invest $100 in an account that earns 5% interest compounded annually, meaning once at the end of the year. How much is your investment worth after 12 years? Okay, we need to figure out, well, growth or decay. In other words, is my money going to grow at the end of the year, or is it going to decrease? And because we're earning interest, okay, and we're investing $100, it should be larger, so it is a positive, meaning it is a growth. So our multiplier is going to be that 100% plus the 5% interest, which changes this to 1 plus that 0.05, or 1.05. So if we start, in other words, our amount, A, is going to get, now remember, this is still y equals a times b to the x, exponential model. A is going to be equal to the amount of money that we started with. Okay, what's the multiplier? Well, the multiplier is that 1 plus 0.05. And then we're going to raise that to how many years? So it's annually each year, and we want it after 12 years. We're going to raise this to the 12, and you should get $179.59. So you start with 100, 5%. At the end of 12 years, it's $179.59. Suppose we take that investment at the 5% annuals, and now it's compounded semi-annually. Meaning, how many times am I going to earn the interest each year? Semi meaning 2. Side note, you do not get the 5% interest every 6 months. So we have to figure out, well, you get what? Okay, well, we have to break this up into 2. So we're going to go 0.05 divided by 2. And then we're going to get that amount every 6 months. So if we look at this over here at the table, 0 years we start with 100. Now we go 6 months equals 0.5 years. Okay, so we invest 100, 1 plus, it's our rate, but now we're dividing by 2 because it's every 2 years. So this is 0.05 divided by 2, and then we want the first year. This gives us, if I can shove this in here, $102.50. So now if we take a year, so we know we're investing 100 years, we're going to get 1.05 divided by 2, but now, in other words, 1 year, so 6 months is 0.5 years, so we get 2 investments, or the interest is earned rate, raised to the second power. Where we get the second power is we're drawing our interest now twice in a year, so semi-annually, so we have to raise it to the second. In other words, how many times are we getting is it being compounded? Which gives us an answer of $105.06. If we look at 1.5 years, in other words, how many times is our interest going to be applied? Well, 1.5 years is now 3 times. 1 plus 0.05 divided by 2 raised to the third. If we go 2 years, now it's raised to the fourth. And if it's t years, we have to think, well, how are we going to get that? Well, we know, what are we doing each time? So number of years would be 1 year, we went to 2. 1.5, we went to 3. 2 years, we went to 4. What's happening? We are multiplying by 2. So it's 100 times 1 plus 0.05 divided by 2 raised to the 2t. These other amounts actually come up to be 107.69 and 110.38. What we're doing, the compound interest formula, what is this? Well, we're taking our amount, okay, the initial amount, and we're multiplying by this multiplier and raising it to a actual, so this is our formula. P times 1 plus R over N equals N times T, where P is the principal, that's our initial amount that we're investing or putting up. Okay, R is our rate or our interest, and we have to change that to a decimal. N is the number of times interest is compounded. And it's broken up, and then T is our years. Okay, now, question, is T always going to be years? No, because there's some bacteria that go in hours and minutes and so forth, so it just depends on the problem. So we need to find the amount of money you will have if you invest $500 for 8 years at 7% annual interest rate compounded, whatever it says. So, for instance, annually will go as 1. If we know that we are, what's our amount that we're investing $500. So we're investing $500. We know our money's going to increase, so it's 1 plus a percentage. The percentage is 7%, so it's 0.07, and we're compounding it annually, so we'll divide by 1. So this is n times t, so n is 1 times 8. So 500 times 1 plus 0.07 raised to the 8th power gives you $859.09. Make sure you plug that in the calculator and check it out. If we skip over to the right real quick, compounded. Well, annually we know is 1. So what's semi? Well, we just did semi-annually on the last page, or last problem. That's twice. Quarterly. Well, quarters are broken up into 4s. Monthly, how many months are in a year? There's 12. Weekly, how many weeks are in a year? There's 52. And daily, there are 365. So we can compound interest through all of these. So hit pause, do B, C, D, and E, and we'll check back in a few seconds. Welcome back. If you notice, this is how it's written. So we're mainly just whatever we compound, we're changing the denominator underneath the interest rate. So quarterly's 4, monthly's 12, daily's 365. We then have to multiply that 4 times the 8 years that we're going to compound it. So B should have been 871.11. C should have been 873.91. And D should have been 875.29. One last little thing what we have to look at is, well, what if they continuously over and over and over and over and over, daily, every second, minute, and so forth, continuously compound this? We're going to use the formula APERT. So your principal interest, E, raised to the RT. So for instance, if we take A equals 500.07 as a decimal rate to the 8 years. Okay, and then that gives us an approximate. So this is APERT. Check the calculator real quick. We're going to go 500. My little E button is a second ln down here, E, and we're going to raise this to 0.07 times 8. When we hit enter, we get $875.34. So that's continuously compounding your interest as much as we can. Don't forget, do your best, forget the rest. Bye for now. Have a wonderful weekend. Take care. Bye-bye.